Hello everyone. In this episode, I'm going to look at the expressions for P1 and P2 in a little bit more detail, mainly by getting some intuition through calculations with some specific numbers, because I think you learn a lot by doing so. Also, I want to begin looking at P1 with an alternative expression for it. You can always calculate P1 starting from that P alpha formula, but after some algebra, here are the main steps, you can see that this is also equal to the head count ratio, H over N, times the normalized income shortfall. The interpretation here is that poverty goes up whenever either of these goes up, whenever either the fraction of those living in poverty is greater or the normalized income shortfall, the fractional income deficits of people go up. And here we can see that this gets at the monotonicity assumption. More specifically, here's a particular example. We'll have an 8-person economy. Just for illustrative purposes, in order to look at poverty, one piece of information you absolutely need is the actual poverty line. We'll make things easy for this calculation and say it's 1. We have 2 people with 0.6 as their income, 2 at 0.8, 2 at 2, and 2 at 6. Again, you can always use the basic P alpha formula, but using the formula that we just expressed a moment ago, we can calculate P1 much more easily. First of all, the fraction who are poor, H over N, with a poverty line of 1, we see that in fact 4 out of 8 are below. In other words, 1/2 on the left there. Proceeding to look at the total income shortfall, we see these 2 people are short by 0.2, these 2 people are short by, these 2 people are short by 0.4, these 2 by 0.2, and that gives us a total shortfall of 1.2. We then divide by the head count, H, times the poverty line, 1, we get an answer of 0.15. To see the difference here, let's look at the same distribution of income and consider P2. So, with regard to using the formula, this is based in equation 5.3 in the text, that P alpha expression, question mark should be at alpha equaling 2, we can then calculate P2 directly. We start with 1/8, because remember we're multiplying all by the fraction, by 1 over the population, to account for the population principle. Then, if you'll remember, we're taking this individual normalized squared poverty amount for each individual poor person. So there are 2 people, once again, whose shortfall is 0.4. So we multiply 0.4 by 0.4 squared, in other words. So we have 0.4 squared plus 0.4 squared. These 2 people have a deficit of 0.2, so we have to add 0.2 squared and another 0.2 squared. Recall that the poverty line is just 1. The result tells us that the P2 value here is 0.05. For these measures, it's important to note, 0.05 might look like a small number, but that's really immaterial. It's a small numerical number because we're squaring a fraction. What you can do is meaningfully compare P2 for one country as against another country. It's never meaningful to compare a P2 with a P1. They're just different kinds of indexes. An alternative expression for P2 is derived in the text and explained in the text at least, and you can see from it that P2 can also be understood as some combination of the head count ratio, the fraction who are poor, the normalized income shortfall, and the coefficient of variation of incomes among the poor. This, when we looked at inequality, I mentioned was a good measure of inequality. In this case, it's the inequality among the poor. And that's similar in spirit, I will say, to the original Sen measure, which had the Gini of the poor, rather than the coefficient of variation. But the Sen measure did not satisfy all of the properties that P2 does. So intuitively, 4 key properties are present with P2. It's anonymous, there's nowhere to put individual names. Population principle, because you're dividing by the population. Monotonicity, because if you add income, otherwise holding everything else the same to any of the poor people, it's going to lower P2 because it lowers one of these squared income shortfalls that we just looked at with the numerical example. And then finally, distributional sensitivity holds because squaring poverty gaps ensures that income provided to a poorer person will reduce P2 more than the same amount of income provided to a less poor person. And so, on that, we'll conclude this episode.